In this video, you will learn how to factor integers. We will begin by discussing the difference between prime versus composite numbers. And then from there, we will learn how to find the prime factorization of a number. And then after that, we will discuss finding the greatest common factor and then the least common multiple. So we need to know what a prime number is and what a composite number is. A prime number, by definition, is a natural number greater than 1 that has exactly two positive factors, 1 and itself. So for example, 2, 3, 5, 7, 11, 13, etc. would all be examples of prime numbers. And the reason is because the only number that you can divide evenly into each of those would be the number 1 and then itself. All right, and that's different than composite numbers, because composite numbers would be something that has more factors than just 1 and itself. So for example, 4, 6, 8, 9, 10, 12, etc. would all be composite. And because if we take 4, for example, the factors of 4 are not just 1 and 4, but we can also have 2, because 2 times 2 is 4. And then if we take, let's say, 18, for example, 18 is composite because not only does 1 times 18 give me 18, but I can also do 2 times 9 and 3 times 6. So 2, 9, 3, and 6 would also be factors, in addition to the 1 and the 18. So composite numbers are the opposite of prime numbers. Next we have what is called the fundamental theorem of arithmetic. So to illustrate, let's say we had the number 12. We can break apart 12 as a product of 4 times 3. And then 4 we can break apart as a product of 2 times 2. So 12 we can write as 2 times 2 times 3. All right, we can also break it apart a different way. We could do 6 times 2, and then 6 breaks apart as 2 times 3. So 12 can be written also as 2 times 3 times 2. So the fundamental theorem of arithmetic says that every composite number can be broken down as a product of prime numbers in only one way. Now the order can differ. So here we have 2 times 2 times 3, and here we have 2 times 3 times 2, but it's still the same product of prime numbers. The order is just different. So we can break apart any composite number like this. And that process is called prime factorization, because we're breaking apart this composite number into a product of only prime numbers. So here's another example. We are told to write the prime factorization of the number 20. So 20 is composite, and we can break apart 20 as a product of prime numbers. So there's different ways we can break it apart, but the end answer will always be the same product of prime numbers. So 20 we can break apart as 2 times 10 or 4 times 5. So we'll do 4 times 5 just because. And now the 4 is still composite. So the 4 I can break down further. The 4 I can think of as a product of 2 times 2. And the 5 cannot break down any further. So here we have now all prime numbers. We have 2 times 2 times 5. None of those can break down any further. So I can think of 20 as a product of 2 times 2 times 5, or also written as 2 squared times 5. Another example, we have 36. 36 is composite and can be broken down as a product of two numbers. We could do 6 times 6 to equal 36. And then 6 is still composite, so I can break that down even further. 6 is a product of 2 times 3. So I have 2 times 3 for that 6, and then 2 times 3 for this 6. So I can think of 36 as a product of 2 times 3 times 2 times 3. Or more simply written, that would be 2 squared times 3 squared. One more example, we have the number 200. 200 is composite and can be broken down as a product of two numbers. We can think of 200 as a product of 20 times 10. both of which are still composite. So 20 can break down further as a product of 4 times 5. And then 10 can break down as a product of 2 times 5. So from here, 5, 2, and 5 are prime, so those are good, but 4 is composite still. 4 can break down as a product of 2 times 2. So we have 2 times 2 times 5 times another 2 times another 5, and that will equal 200. And a simpler way of writing this is we have 2 to the third power times 5 to the second power. So once you know how to prime factorize a number, we can use that to find the greatest common factor as well as the least common multiple. So the greatest common factor between any two numbers is the greatest number that is a factor of each. So for example, if we had 8 and 12, what is the greatest common factor of 8 and 12? Well, the answer is 4, because that is the largest number that is a factor of both 8 and 12. Another way of putting this is your answer is 4, because that is the largest number that we can divide into 8 and 12 both. All right, 8 divided by 4 works well. 12 divided by 4 works well also. So because of that, 4 is your greatest common factor. So we don't want to have to guess every time or try to think through every possible number to get our solution. We want to have a process in place to determine the GCF, or greatest common factor. So using the same example, the numbers 8 and 12. So the process is as follows. I can break down 8 and 12 as a product of prime numbers. So 8 I can factor down to be 4 times 2. 4 can factor down to be 2 times 2. So 8 can be written as 2 times 2 times 2. Same thing for 12. 12 is a product of 4 times 3. 4 can break down as 2 times 2. So 12 can be written as a product of 2 times 2 times 3. So to find the greatest common factor, once I have the prime factors listed, I can see which factors they have in common. So notice they both have a 2 and another 2. So I take 2 times the other 2 to get 4 as my answer, which is what we got in the previous slide. All right, here's another example. Find the greatest common factor of 12 and 24. So once again, break down 24. That's 4 times 6. 4 is 2 times 2, and 6 is 2 times 3. So 24 is a product of 2 times 2 times 2 times 3. And then 12 can break down as 4 times 3. 4 can break down as 2 times 2. So 12 is a product of 2 times 2 times 3. So once we've done this, we can see which factors they have in common. So notice we have 1 pair of 2's, 2 pair of 2's, and then a 3. So I take the 2 times 2 times 3 to get 12 as my greatest common factor. And I can double check to make sure my answer makes sense. If I take my answer, we see, does this divide evenly into both 12 and 24? And the answer is yes. So this one, this answer makes sense, and this would be the correct answer. All right, now what if you had 3 numbers? Here we have 12, 24, and 30. Well, it's the same exact thing. So we've already done 12 and 24. We've broken those down. And that was done in the previous slide. So we're going to skip over this. 24 was 2 times 2 times 3. 12 breaks down as 2 times 2 times 3. And now 30, we need to break this one down as a product of prime numbers. 30 can be written as 6 times 5. And then 6 can break down as 2 times 3. So 30 can be written as 2 times 3 times 5. So the process is exactly the same with 3 numbers as it is with 2 numbers. And at this point, I need to see what factors do all 3 have in common. So notice they all have a 2 in common, and they all have a 3 in common. So the greatest common factor of those 3 numbers would be 2 times 3, which would equal 6. And notice 6 does divide evenly into 12 and 24 and 30. So this answer makes sense, and it is the correct answer. Okay, here's an example where now we throw in some variables. So now we have 10x to the fourth power times y and 15x squared times y squared. So what we want to do is break apart the 10 and the 15. So 10 is 2 times 5, 15 is 3 times 5. And it's helpful, at least to think through this process. You don't need to write this down every time. But if you could visualize the x to the fourth as being a product of 4 x's. So here we see 10x to the fourth times y. 10 is 2 times 5. X to the fourth is 4 x's multiplied together. Then you have the times y as well. Same thing for 15. 15 is 3 times 5. Then x squared is x times x. And y squared is y times y. So at this point, we just see what they have in common. So we see a pair of 5s, a pair of x's, another pair of x's, and a pair of y's they have in common. So the greatest common factor is a product of 5 times x times x times y. So just multiply the things that they have in common. And then x times x I can write as x squared. So what I have is 5 times x squared times y, which can be written like this. Now you don't need to actually write out the variables every time, but it's helpful to maybe think through that process at least. So if we wanted to, right at this point up here, we can see that the variables, see what they have in common. This one has 4 x's, this one has 2. Well, they both have 2. This one has more than 2, but they both do have 2. So 2 x's is what they have in common. And then the y's, this one has 1 y, this one has 2 y's. Well, they both have 1. Right, this one has more than 1, but they both do have 1 y. So the variable part can be found pretty quickly just by looking up here at the initial question. And then you have to figure out the 10 and the 15 and find that the greatest common factor of those would be 5. All right, so that would be your answer. Now lastly, we're going to deal with least common multiples. So we need to understand what a multiple means before we can find the least common multiple. So here we see a table, and we're going to find the multiples of 3 and the multiples of 4. So multiples of 3 means that I'm going to multiply 3 by the natural numbers. So 3 times 1, 3 times 2, 3 times 3, etc. So if I fill in this table, I'm going to get 3 times 1 equaling 3, 3 times 2 is 6, 3 times 3 is 9, and etc. The multiples of 4 mean that I multiply 4 by the natural numbers 1, 2, 3, 4, etc. So the multiples of 4 would be 4, 8, 12, 16, 20, 24, 28, and 32. And that would keep going, by the way. Both of these would keep going forever. Now, common multiples are multiples that both pair of numbers have in common. So notice they both have 12 in common, they both have 24 in common, and that would keep going for infinity. But what we're concerned with is the least common multiple. What is the smallest number that they have in common? And that smallest number would be 12. So the definition of least common multiple is the smallest number that is a multiple of each of the given numbers. So I would say the least common multiple of 3 and 4 would be 12. All right, so here we have another example. You are to use that same process to find the least common multiple of 8 and 10. So what we do, if we're using that method we just used, we would start with 8 and list all the multiples of 8. So 8, 16, 24, 32, 40, etc. And then the same thing with the 10. List the multiples of 10, which would be 10, 20, 30, 40, 50, etc. So to find the least common multiple, I see which multiple is the smallest that they have in common. And that would be 40. That's the smallest number they both have in common. So I would say the least common multiple, or LCM, of both those numbers of 8 and 10 would be 40. Now we don't want to have to list the multiples every time to find the least common multiple. It would work, but it could be tedious to do that. So our objective now is to have a method in which we can calculate the least common multiple. So using the same numbers, 8 and 10, I want to figure out how to calculate this. So what I want to do is break apart 8 and 10 as a product of prime numbers. So I find the prime factorization of both of those. So 8 I can break down, and that would be 4 times 2. 4 breaks down as 2 times 2. So 8 would be 2 times 2 times 2. And then 10 would break down as just a product of 2 times 5. So once we do this, then we can find the least common multiple very quickly. So the process we want to use is we look to see what factors we have represented. So we see there are 2's and there are 5's. All right, so we have 2 and 5. So what I do is I take each of those factors and see which number, either 8 or 10, has the most of them. So starting with the 2's, we take all the 2's from the number that has the most. So we see 8 right here. 8 has the most with 3 2's. 10 only has 1 2. So we take the one with the most, so we take all 3 of these 2's. And then we have 5's as well, so we see which one has the most 5's. Well, 8 has no 5's, 10 has 1 5, so 10 has the most, and we take all of its 5's, which in this case is just one of them. So I put that with the 2's as well. So we have 3 2's and we have a 5. We multiply those together, and that gives me my answer of 40. Okay, here is another example. What if we had 4, 6, and 15, and we were told to find the least common multiple? So we break apart the 4, 6, and 15. 4 is 2 times 2. 6 can break down as 2 times 3. And 15 breaks down as 3 times 5. So once we do that, now we determine which factors we have represented. Well, we have 2's, we have 3's, and we have 5's. So the question is, how many of each do we take? So we take the number with the most. So starting with the 2's, which number, 4, 6, or 15, has the most 2's? Well, 4 does. 4 has 2 2's. So we take all of its 2's. All right, so we have 2 times 2. And then same thing with the 3's. We see which one has the most 3's. Well, it's a tie. 6 has 1 3, and 15 has 1 3. So I just take the one with the most, and since it's a tie, we just take either one, doesn't matter, but we're only taking 1 3. So we have 1 3 that we put with the 2 2's. And then we look at the 5's, see which one has the most 5's. So we see 15 has the most 5's with one of them, so we take all of its 5's, which is 1. So then we put that over here with the 2 2's, the 3, and the 5. Multiply those numbers together, and we get 60 as my answer. And I can double check that, just do a quick mental check. If I were to find the multiples of 4, if I take 4 times 15, that gives me 60. So 60 is a multiple of 4. 6 times 10 is 60. So 60 is a multiple of 6 as well. And 15 times 4 would be 60. So 60 is a multiple of 15 also. All right, and lastly, we need to know how to find the least common multiple with numbers and variables together. So here we have 12x squared y and 14x cubed y. So I factor down the 12 and the 14. 12 I can break down. That would be 2 times 6. 6 is 2 times 3. So 12 would be 2 times 2 times 3. And then we have times the x squared times y. 14 can break down as 2 times 7. So 2 times 7 times x to the third times y. So from here we see which factors we have represented. We see 2's, we see 3's, 7's, x's, and y's. So the question is, how many of each do we take? So looking at the 2's, we see which one has the most. Well, 12 has the most 2's with 2 of them. So I take both of those 2's. So I have two 2's put together. And then the 3's, 12 also has the most 3's with just 1. So I take that 1 3 and then put it with the 2's. And then I look at the x's. Or no, the 7's, sorry. So the 7's. 14 has the most 7's with 1. So we take 1 7. We put that with the 2 2's and the 3. And then the x's, we see which one has the most. Well, 14 x to the third times y has the most with 3 of them. So we take all 3 of the x's. All right, so we have x to the third as well. And then lastly, do it with the y's. So they both have 1 y, so it's a tie. I can take either, doesn't matter, but I'm only taking 1. So I have 1 y put in there as well. So I put all of that together by multiplying. 2 times 2 is 4, times 3 is 12, times 7 is 84, and then times x cubed times y. So this would be my solution. And that concludes our lesson for today. We will see you next time.